Everyone, and welcome to activity 32. Today we are going to start talking about vectors and talking about vector positioning and some vocabulary with them, starting on page 443 in your Springboard books. On page 443, we see a lot of vocabulary about vectors, which you may or may not have seen so far from your physics class or remember from physics. And basically, a vector is a mathematical quantity that has both a magnitude and a direction. And a vector is represented by a directed line segment. Now, notice when we talk about vectors, it's not brackets in the traditional sense. It's more this pointed bracket, almost like an arrow of some sort. And that's talking about how much you are moving right and left, up and down, moving from a tail to the head. And that distance between the tail and the head, the length of the directed line segment, is called our magnitude. Okay, so there is a difference between just talking about a location of a point versus what a vector means. Again, the horizontal movement and the vertical movement, A and B. And then the magnitude, think, kind of Pythagorean theorem. It's been a common theme throughout the past couple of units. But that length represented by these absolute value bars for the magnitude. So we see here some examples where that they've done, where we have the tail at 1, 2, the head is at 3, -2, drawing that in and then labeling. And then when we have standard position, that's when our tail starts at 0, 0, and then the head is here at -4, 3 because we move to the left 4 and up 3. Okay, so again, standard positions, the tail is at the origin. Now, vectors are said to be equal if they have the same magnitude and direction. Okay, so these would not be equal even if they had the same magnitude because the directions are different. They're not pointing the same way. Okay, and then we have some of these that are part of the try these section. We want to draw each of these on the coordinate plane. So for the first one, when we want to draw the vector in standard position for part A, well, that means the tail is going to start at 0, 0. And we are moving to the right 2 and down 5 on here. So we would have our head here at 2, -5. And you want to make sure you're representing this then with an arrow point. Okay, so this is vector V. Now part B is asking us to draw a vector with a tail at -4, -2, and the head is at -2, -2. So that would be here. And again, we have to show, since it's a vector, the direction. So we draw in our arrow there. Here is vector U. And then last but not least, for part C, we have a tail at -1, 2, and then we are moving to the right 3 and up 3. So right 3, up 3 would put our head here at 2, 5. And again, you want to make sure you draw in these arrows. Okay, and this is vector T. Now, on the next page, on page 444, we have this next example asking about, again, looking at, okay, here's the head, here's the tail. Would these vectors be equal? Well, we need to look at the direction and then obviously kind of magnitude, how much we're moving. Now, both of these appear to have the same direction, kind of pointing that same way, but they have different magnitudes because we see this first one in standard position move to the left 3 and down 4, so it would have -3, -4, as opposed to our second vector, vector V, we moved to the left 3, but down 5. So since the component forms, which is what we call this here, are not the same, these would not be equal vectors. Okay, so we have a couple examples down below. We have, for example, B. And an important thing to note too before we move on, to find the component form given just the values of the head and the tail, you always want to take the values from the head, the x coordinates, and then subtract away the other x coordinates, and then same thing with the y's to get the A and the B, okay, to get your component form. So if we look here at U and V, again, vector V, so here, we moved to the left 1, 2, 3, 4, and then we moved up 1, 2, 3. So vector v has a component form of -4. Oh, excuse me. Let me look at my scale. Sorry, these are going up by 2s, so be careful. 4, 6, 8. So actually we went to the left 2, 4, 6, 8, and then up 2, 4, 6. And then vector u went to the left 2, 4, 6, 8. And it went up 2, 4, 6. So since these are identical, the component form's the same, we would say yes, these vectors are equal. Now on the second one, you should have looked at this and said, okay, we said from up above, we know that this is -8, 6, component form of t. Move to left 2, 4, 6, 2, 4, 6. Well, left 6, up 6, these do not match. So we would say, no, these vectors are not equal. Component forms are not the same. Okay, so showing that to support our answers as well. Now, if you don't have just the lovely pictures to count, again, to get your component form, you're going to take your two values. Again, it's always head minus tail. So we would take 12 minus -8 for A, and then our two values here, again, head minus tail, -15 minus 6, for our final answer of 20, -21 would be our component form, again, subtracting those. So a little bit similar to slope, but not really. Just be careful of, again, subtracting head minus tail. Now, down below here at looking at these, if we talk about some movements, again, just some vocabulary things to be aware of. When we talk about your head and your tails, remember the tail will always be your starting position, while the head is going to always be the end or final position. And then when we talk about the movement, remember your direction is going to be considered your direction moved, quite literally. While if they ask us to find the magnitude, that's going to be the length between your starting and your final point, right? So again, that's length. Okay, so just again, some review of the vocabulary, because as we start talking then, number 2 on the page, top of page 445, if they're giving us these components, again, the component form, if they're talking about the robotic arm starting at 50, 120, and then on a coordinate plane measured in centimeters, and it's moving to 9865, well, our starting point, we always say, is the tail. Then we would have the head would be this final position here. So if they're asking us for the component form, again, it's always head value minus tail value. So we would take 98 minus 50, our two components here and here, and then 65 minus 120, those y components to make up b, for a final component form of 48 -55. And what this represents, again, component form is talking about the fact that we're now moving 48 centimeters right and 55 centimeters down, since it's negative, from our initial spot. Okay. And our magnitude, it's been a little bit since we talked about this, but from the first page, remember your magnitude is the absolute value of a squared plus b squared. So we had to take those two components of 48 and -55, aka positive 55, when we square it, and get our final answer of 73. Okay, and what this is basically telling us is that we are 73 centimeters from our initial position. the length of this. Again, you think right and down, it's kind of like saying at the length of our robotic arm this way, from that starting point to the end. Okay, now to kind of finish this out, we will be working more with this in class, but you're definitely going to want to talk about and know what the vector form, the component form, and our magnitude are, and we will talk more about kind of dealing with operations of vectors in the next class. Thank you.